Okay, so this is the final lecture for Chapter E. Shouldn't take very long. I'm just going to work out a few problems and teach you how to properly set up conversions, especially multi-step conversions. This will also be important for several chapters to follow. Okay, so a fancy name for a very simple thing. Okay, we can calculate how many dollars 2.5 pounds of bananas cost based on the conversion factor $1 per pound, okay, which we can do in our head, because if it's $1 a pound, then 2.5 pounds of bananas is going to cost us $2.50. But I'm using this very simple example to illustrate how factor label method works, right? So a conversion factor that we use would be $1, and I'm going to write it like this. So the unit follows the number, okay, equals 1 pound. We set this up, we either multiply or divide, and we've done this already. I've shown this to you already, I just didn't give it a name. But if we have 2.5 pounds of bananas, then what we do is we take this conversion factor and we multiply by the unit we want, so $1.00, I'm going to write it like this because I'm going to run out of space, and 1 pound for the sake of canceling the units. Okay, and I should write bananas so that bananas cancels as well. So, and we will see this for conversions between grams of a reactant and grams of a product. Okay, so this is called the conversion factor method or factor label method. Let's practice that. How many grams are contained in 57.5 milligrams? In order to work this problem, you have to look up the conversion factor. And so this is just a single step, so it's not a big deal. This comes from the metric to metric conversion chart, and the little m is a milli, which means that 1 milligram is equal to 10 to the minus 3 grams. And the factor label method then simply takes the 57.5 milligrams, divides by milligrams, and multiplies by grams. 10 to the minus 3 grams. Milligrams cancels. We have 57.5 times 10 to the minus 3 grams. And to move this into a better form, we should write 5.75 times 10 to the minus 2 grams, simply moving over the decimal by 1, which decreases the factor here, the minus 3 to minus 2, and so this is not a big deal. Another single conversion factor conversion here. The distance to the sun is 1.50 times 10 to the 11 meters. How many kilometers is that? Okay, so meters to kilometers, we know that 1 kilometer is equal to 10 to the 3 meters. K is a prefix of 1,000, and so we have 1.50 times 10 to the 11 meters times 1 kilometer divided by 10 to the 3 meters will give us 1.5 times 10 to the 8 kilometers. And I forgot the 0 because we have 3 significant figures. Alright. Okay, make things a little bit more complicated, add a second step. A 150 liter hot water tank has what volume in meters cubed? Okay, if you remember the conversion factor, that 1 liter is equal to 1 decimeter cubed, then you convert from the liter to the base unit, and then we need to of course go from, the second conversion would be from decimeters to meters, and so 1 decimeter is equal to 1 times 10 to the minus 1 meters. So we have two conversion factors and we set them up in a row. Okay, so we start out, and I'm going to go ahead and convert that to scientific notation. 1.5, this way I can drop the 0, times 10 to the 2 liters times 1 decimeter cubed divided by 1 liter. The liter goes away, and so this should just be a 1 or nothing decimeter cubed. And this is where you need to pay attention. The next conversion factor would then be going to meters, so it's 10 to the minus 1 meters divided by decimeters. But this is cubed, so I have to cube the whole thing. And so at the end of the day, this turns out to be 1.5 times 10 to the something meters cubed. And so here you just add up all of the factors. You have 2. This, of course, it's going to cancel. And then 10 to the minus 3. So it's 2 minus 3. And that gives us 10 to the minus 1 meters cubed. So the answer is 1.5 times 10 to the minus 1 meters cubed. So you just keep setting up these steps where you cancel one unit and come out with a new until you reach the unit that we're after. So here we're after meters cubed. Again, another volume one. What is the volume in meters cubed of a 20-liter aquarium? All right, we work this the same way. We start out with 20 liters, not just going to leave it, change it to scientific notation later on, times 10 to the minus 3 meters cubed per liter, which is equal to 20 times 10 to the minus 3 meters cubed. Or, and we need to get rid of that 0, so 2 times 10 to the minus 2 meters cubed. Okay, so I'm just using a different conversion factor here. Okay, okay, work a few more. How many meters are contained in 37.6 millimeters? 37.6 millimeters, and there are 1 millimeter has 10 to the minus 3 meter, so it is 3 point, moving the decimal, 7.6 times, whoops, that's supposed to be a 7 times 10 to the minus 2 meters. These are really simple and they get more complicated. I encourage you to work homework E, which is posted on Canvas. 4.75, capital M is a megagram, times 10 to the 6 grams per megagram equals simply 4.75 times 10 to the 6 grams. And finally, a metric conversion to well, no, it's picometers to centimeters. So this is a two-step conversion. It's going to get a little tight for me down there on the device I'm using, but you have 2.54 centimeters. Step 1, there's 10 to the minus 2 meters equal to 1 centimeter. And in the second step, we convert to picometers, meters to picometers. And 1 picometer is 10 to the minus 12 meters, which equals 2.54 times 10 to the 10 picometers. It's just minus 2 minus minus 12 equals 10. That's how that works. Okay, 3 more. How many centimeters are contained in 275 inches? Okay, so now it's metric, and the conversion factor is 2.54 centimeters equals 1 inch, right? 275 inches times 2.54 centimeters divided by 1 inch. Inches canceled, we get 699 centimeters, roughly 2.5 times more. 275 times 2.5, that's roughly 700, right? So 3 sig figs, 699 centimeters. How many grams are contained in 175 pounds? Single step, we know that 1 pound equals 454 grams. So 175 pounds times 454 grams divided by 1 pound equals 7,950 grams, or 7.95 times 10 to the 3 grams. Okay, sorry about that. That's a 10 to the third factor of 1,000. Okay, moving the decimal by 3. How many cubic meters are contained in 50 gallons? Okay, though that's, we're going to have to convert gallons to liters, and then we know the relationship that 1 liter is equal to 10 to the minus 3 cubic meters, and go from there. All right, so the conversion factor from gallons is 50 gallons, and there are 3.785 liters in 1 gallon. And there are other ways to go from liters to cubic meters, okay? But we already know that there is 10 to the minus 3 meters cubed in 1 liter. We established that earlier. And so we get 2, see that 0 is not significant, so we just get 1 sig fig. 2 times 10 to the minus 1 meters cubed. Okay, this is just a solution so you can read it better. That's exactly what I was doing, and it looks like I made a mistake here, which is kind of nice that I caught that, right? So this is not times 10 to the 3. We moved it over 1, 2, 3. The heck did I do there? It's got to be that it's another 0 here. When you check it in the in your calculator, take 175, multiply by 454, and see if I missed a 0 there, and fix that. All right. So just note that I made a mistake here, and so I just forgot a 0. All right. Let's work a couple more, and then we're done. The world's oceans have a volume of 1.35 times 10 to the 9 kilometers squared. How many gallons is that? All right, so we start out with 1.35 times 10 to the 9 km cubed. Okay, so now we can go from km, so, and you have to cube that, right? So there's 10 to the 3 meters for 1 km. But this we have to cube because of the unit, right? So then it's going to be 10 to the 9 and 10 to the and km to the QB power. All right. And then we can go to gallons, because that's going to be equal to, sorry, we need to go to liters first. So 1 liter equals 10 to the minus 3 meters cubed. Okay? And then finally, we can go to gallons. 1 gallon is equal to 785 liters. And the answer then, you punch that into the calculator, or and so it's 3.57 times 10 to the 20 gallons. So that's quite a few gallons. So make sure that you can actually just take 1.35 and divide it, because everything else is just a factor, and divide it by 3.78. And when you do that, and I'm going to write that up here, okay? When you do that, you get 0.357, and then everything else is a conversion factor. It's just a scientific notation, right? Because we have 10 to the 9, okay, and we have 10 to the 3 to the third power, which is also 10 to the 9. So that's 10 to the 18 already. And then we divide it by this factor, which is 10 to the minus 3. So that's going to be 10 to the 18 plus 3, that's 10 to the 21, right? Times 10 to the 21 gallons. And if I just move this over, that decreases to 10 to the 20. Okay, that's really, you want to do it that way. It's easier, then you don't have to worry about scientific notation in your calculator. But in the end, it's you who's taking the exam. Okay, so now we are going to do one last problem. The mass of an electron is 9.12 times 10 to the minus 32 kilograms. How many pounds is that? Okay, not a problem. 9.12 times 10 to the negative 31 kilograms. Let's convert to, or we don't even need to, we know they're 2.2 pounds times 2.2 pounds. You can use this conversion factor per kilogram, and we get 2.01 times 10 to the negative 30 pounds. That's pretty heavy? No, that's very, very small. Okay, that's, because this is the end of the lecture. This is all nicely worked out here, so you can look that up. I'm going to have one more lecture on the homework, but you can skip that and start with chapter 1 if you like.